and welcome to the mathleague YouTube channel. The following video was recorded by one of our staff members live at one of our contests.
Oh, hi. Hi there. So let's go ahead and do this team problem. So Mumei forgets what her favorite number is. Oh no. She first remembers that it is a 3-digit perfect square. So we'll write down a bunch of perfect squares, I guess. She then recalls that her favorite number is a multiple of her house number, which is a positive number relatively prime to 30. But she still can't tell what it is from this information. So this will be important to keep in mind. And then she remembers that all of the digits in her favorite number are distinct, and she is able to deduce what her favorite number is. So how in the world do we ever get to approaching this logic problem? Well, first, let's go ahead and write down all of the 3-digit perfect squares that are a multiple of some number that is relatively prime to 30. So we ought to go ahead and do that. Shall we? So let's write down a bunch of perfect squares. And we could keep on writing these, but let's go ahead and I guess categorize these by the particular house number. So if the house number is 7, then the favorite number could possibly be, let's see, 196, 441, and 784. So does this work? The thing is, now, if she remembers this, she can't deduce which house number it is, but if she remembers all of the digits in her favorite number that are distinct, then it still could be one of these numbers. So the house number can't be 7. So let's go up to house number 11. So what do we do here? For house number 11, we can find that it could be 121, it could be 484, and then larger perfect squares divisible by 11 are larger than 1000. But both of these have repeated digits, so this won't work either. Then let's go to 13 next. So 13 gives us the house numbers 169, and 676, 26 squared. And what happens here? If she remembers that all of her digits in her favorite number are distinct, then she can eliminate this, and this will be the remaining house number. So this is a possible number, and since answers are unique in these problems, we can deduce that 169 has to be the answer. But just to make sure, we can look at some other larger house numbers, perhaps. All larger house numbers would lead to a scenario where, for example, with 17, we would have 289, but 289 would be the only option. And all other perfect squares larger get larger than 1000. So this would be the only house number. But this is where this info comes into play. She can't tell what the house number is from this information. And if her house number was 17, then this would be the only number that would be an option. So it can't possibly be a house number of 17 or anything greater. So the house number has to be 13, and her favorite number has to be 169. So that's it. I forgot what I was going to say, so I'll just tap out.
Hi, everybody. This is Tim. Hope you're enjoying our videos. If so, you know what to do. Like, subscribe, turn on notifications, all that sort of thing. But what I'd really want to invite you to do is to send us an email at media@mathleague.org. Tell us which problems you'd like to see us cover next in our video series. Take care and see you in the next video.